Dear students, today we are going to talk about refraction and the law governing refraction of light. Well, you see, we have already learned about refraction of light in junior classes. Still, we recall it. Whenever light ray enters from one medium into another medium, which is obliquely incident on the surface separating these two mediums, then the light ray on entering the second medium changes its path. This phenomena is known as refraction. Well, for example, if we consider a light ray coming from air medium and entering water medium, and we call it air medium as the first medium and water as the second medium, then if the light ray is incident obliquely on the surface separating air and water, as you see in the figure, then in this case the light ray is bending away from its original path, which is shown by dotted line, and the light ray is bending towards the normal. What is normal? Normal ON1, ON2 is a line which is drawn perpendicular to the surface separating air and water medium. If we call water medium as the second medium and air as the first medium, then the law which governs refraction of light, which is known as Snell's law, states that the sine of the angle of incidence, what is angle of incidence? You see, the incident ray AO, whatever angle it makes with the normal is known as angle of incidence, and the refracted ray OB, whatever angle it makes with the normal ON2 is known as angle of refraction, and the ratio of sin I by sin R is always a constant known as a refractive index of second medium with respect to first medium, and mathematically we write it sin I by sin R is equal to mu2 refractive index of second medium with respect to first medium. In this case, second medium is water and first medium is air, and we take second medium, that medium in which the light ray is entering coming from another medium, and we take that medium as first medium from which the light ray is coming. So this refractive index is also represented by n. Well, you see, if we have a case that light ray is incident from denser medium into a rarer medium, that means in this case water is the first medium and air is the second medium, then we have sin I1 by sin R1 equal to refractive index of second medium, that is air, with respect to first medium, that is water. So we write sin I1 by sin R1 equal to refractive index of air with respect to water. To avoid confusion, because here something water is the second medium and here water is the first medium, so we have introduced the name of the medium so that we don't have any confusion, and we will see that sin I1 by sin R1 is nothing but reciprocal of mu2 How this happens, let us understand. If we take a plane mirror and place it in a position such that the incident ray makes 90 degrees to the mirror, in that case the light ray will retrace its path, will return back on its own path, because when light ray is incident perpendicularly to a surface, it returns back to its own path, and therefore after entering the air medium, it will follow the same path OA. this principle is also known as principle of reversibility of light. So that means if we have angle of incidence equal to R over here, means I1 is equal to R. If we have I1 is equal to R, means angle of incidence, light ray incident on air medium from water medium, and angle of incidence is equal to R. That means I1 is equal to R. Then certainly we will have R1 equal to I, because light ray is retracing its own path, and therefore I1 is equal to R and R1 is equal to I, and therefore if we feed this value over here, we have sine, for I1 we write R divided by, for R1 we write sine I, and that is nothing but refractive index of air with respect to water, and that is nothing but 1 upon sine I by sine R, and sine I by sine R is nothing but refractive index of second medium, that is water medium, we can say, with respect to air, or we can also write if we take this standard name. So I think there is no confusion about it, how to express the refractive index of one medium with respect to another in terms of angle of incidence and angle of refraction. So most fundamental thing is you remember that sine of the angle of incidence to the sine of the angle of refraction is always equal to refractive index of second medium with respect to first medium. So this is about it, and we must remember that whenever light ray enters a denser medium, the light ray moves towards the normal, bends towards the normal if the light ray is incident obliquely. And whenever light ray is entering a rarer medium, when the ray is incident obliquely, then the light ray will bend away from normal due to refraction. So this is all about refraction. Now we can have one question about the laws of reflection and another question about the law of the pattern for refraction. Well, you see, in the case of reflection of light, we have learned that incident ray, reflected ray and normal all lie in the same plane, and also angle of incidence is always equal to angle of reflection. Well, why this happens? What is the reason behind it? To understand, we can go through the example we have learned in class 11 about a ball hitting a wall and returning back. There we have seen that the transfer of momentum, change in momentum, the force applied on the wall is always along a direction perpendicular to the wall. And to have this condition satisfied, we have this angle of incidence is equal to angle of reflection, and incident ray, reflected ray, normal all lie in same plane, because light is also like a particle, energy particle called photons. So we can take it like a particle, and when it is incident on some surface, it is reflected back and follows the same law of reflection. That is, angle of incidence is equal to angle of reflection, and incident ray, reflected ray, normal all lie in the same plane. This is because the transfer of change in momentum, the force applied on the surface is always along direction perpendicular to the surface, and to maintain this there has to be angle of incidence has to be equal to angle of reflection, and incident ray, reflected ray and normal must lie in same plane. This condition could be understood if you go into details, refer to that example and look into the case by varying the angle of incidence different from angle of reflection and not keeping these three angle of the incident ray, reflected ray and normal, that is in the same plane. If we don't keep them in the same plane, you don't have the condition satisfied. The condition is that the transfer of the force applied on the surface must be perpendicular to it. Essentially, at whatever angle we incident the object on the surface, and therefore we must also have the condition satisfied that angle of incidence is always equal to angle of reflection. Now there is one more question regarding the refraction of light, which we are not now in a position to answer it, but I want to put this question in your mind. Why this happens that when obliquely incident light ray enters second medium from the first medium, it changes its path, but a normally incident light ray on entering second medium from first medium, it is not changing its path? We shall be in a position to understand the answer to this question after we have learned certain aspects in the following chapter. Till then, we have to wait for the answer to this question. Thank you and have a nice day.